According to life science, chemical engineering is a branch of engineering that uses processes of chemistry, physics, mathematics, biology, and economics to effectively use, produce, design, and transport and transform energy and materials. In this project, we will explore the practical application of this discipline by creating milk art. The process will be further explored and explained in this lab, making each of you chemical engineers.
The first key point we will be talking about is surface tension. This is an effect where the surface of a liquid appears stronger than the bulk. In the bulk of the liquid, the molecules are being pulled in every direction, which results in no net forces. The molecules at the surface of the water do not have molecules above them, so they are pulled inward. This creates internal pressure, which forces the liquid surface to contract to minimize the surface area.
The second important concept is surfactants. A surfactant is a substance that reduces the surface tension of a liquid that it is dissolved in. A common example of a surfactant is soap. Surfactants are composed of both hydrophobic and hydrophilic groups. Hydrophobic means it does not like water, while hydrophilic means it does like water. This concept is why soap is able to react with oils and then be washed away with water. I know this is a lot of information to absorb all at once, but just remember that surfactants make surface tension weaker and allow oil to mix with water.
Now that we know all about surface tension, let's take a look at some simple examples. If you have water, a penny, and a paperclip handy, you can follow along at home. Do you think a paperclip will float in water? Let's see. The paperclip is able to float because the water molecules are holding on tightly to each other. This is called cohesion. Next, we'll try the penny. Do you think it will float too? Make a prediction. As you can see, there are limits to how much weight the surface tension of water can hold. A penny does not float because it is more dense than water. How many water droplets do you think this penny will be able to hold before the water spills over the edge? Notice that a dome of water begins to form on top of the penny. The bubble shape is another example of cohesion and surface tension at work. The tiny water molecules on this penny are attracted to each other. They make a sphere because they are trying to take up as little space as possible.
Here are all the ingredients you'll need to make your very own milk art. So first, you're going to need a bowl. Then you're going to need some food coloring right here, some soap. I have dish soap right here, some Q-tips, and then of course your milk. So this is whole milk that we're going to be using. So you can use your favorite color for food coloring, so you can choose whatever you want. You'll want to pour some milk into the bowl. All right, next you'll want to put some food coloring in, and you can choose whatever you want. Right here, I'm going to be using some blue. I just put in a few drops here and there, and then I'll probably use some pink too. All right. After you do that, look closely at the food coloring. You can see that the food coloring is just by itself, like it's not spreading into the milk really. So why do you think the food coloring isn't spreading into the milk? The reason why the food coloring sits on top of the milk is because the milk has fat in it. The fat is connected by bonds, which is like little pieces of fat all holding hands with each other, so they're connected. The food coloring can't get through those bonds, so it doesn't spread out. It just sits on top of it and doesn't mix with the milk. So now what will you think will happen if we add some soap to it? So let's try that. I'm gonna go ahead and put some soap onto this Q-tip, like that. All right. Now we're gonna touch it to the food coloring. Look at that. Wow. Look at what happened. So this soap is a surfactant. So it broke apart the bonds in the milk fat and it allowed the colors to mix into the milk. Feel free to get as creative as you want with your colors and make your own beautiful milk art. So go ahead and have fun and make your milk art.
Once you guys have finished your activity, these are some extra things that you can try out just to learn more about surface tension. You can try using whole milk or skim milk and see how those react differently. Or you can add pepper to see what happens. Or you could even change the temperature of the milk. Good luck.
Okay, I think that was fine.
Okay.